Okay, so the mean value theorem is actually a really important theorem in calculus. It's one of the big theorems in calculus, and so this is one that's important that you understand and are able to apply. So just so you know, I will usually abbreviate this MVT for mean value theorem. And then let's go ahead and state the theorem. So it's actually going to be pretty similar to Rolle's theorem. These are very related. So we start with a function, and it will satisfy some conditions. Satisfies. So first of all, f is continuous on the closed interval a to b, and f is differentiable on the open interval a to b. Okay, and then if these two things hold, then there exists a number c in the open interval a to b such that we get f prime of c is equal to f of b minus f of a over b minus a. Okay, so let's think about how this is different than Rolle's theorem. Well, first of all, there are only two conditions, so we don't have the condition that f of b should be equal to f of a. But the first two conditions are actually the same. So that f is continuous on the closed interval and differentiable on the open interval. Those are exactly the same as Rolle's theorem. And then the conclusion is different. So instead of having a number c where the derivative is equal to 0 at c, we have that the derivative is equal to this thing. So this should actually look familiar, hopefully. So notice that f of b minus f of a over b minus a, that's the average value or average rate of change of the function on that interval a to b. Or another way that we think about this is that this is the slope of the secant line. From a to b. Okay, so if we want to picture this, say I have a function on an interval a to b, and so say f of a is here and f of b is here, and my function looks something like this. Then you can see that, let me do this in a different color. If we were to draw the secant line from a to b, that would just be the straight line that connects those two points of the function. I'll try to straighten this out just a little bit. Right. So this here is the secant line. And so what this says, f prime of c equals f of b minus f of a over b minus a, is that somewhere there is a point where the slope of the tangent line is equal to the slope of the secant line. So we can see that we would have approximately here that the tangent line has the same slope as the secant line. So they're both exactly sloped in the same direction, and that would be our point C. So tracing this down to the domain, we would have C right here, right? Okay, so I'll try to squeeze this in here. like right here. So the mean value theorem says, well, if f satisfies the conditions that I won't write out, so if f satisfies 1 and 2, then there's a point in the interval a to b such that the tangent line has the same slope dang it, as the secant line. Sorry, I did not leave myself enough room. Okay, so yeah, so that's what it says. So that's a way of remembering it that maybe is a little bit easier than the exact statement, in my opinion. I think it would be easier to remember that way. Okay, so let's go ahead and do an example. So this will be similar to the first example that we did. Okay, so this one asks us to determine numbers where the that satisfy the conclusions of the mean value theorem. Here we're given this interval, -2 to 2, and our function is this cubic function. So when we're starting out, the first thing that you want to do is actually compute, well, you could do these in either order, but we will want to take the derivative and then compute the slope of the secant line on this interval given. So let's start with computing the slope. So that would be my b is 2 and my a is -2. So I would get this, and then I just use the formula that I'm given for f to compute this. So plugging in 2, I get this, minus plugging in -2, and then this simplifies to 4 in the denominator, right? Okay, so simplifying, we would get 8 minus 6 plus 2, so that would give us just 2 for that piece. And wait, no, 8 plus 2, that would give us 4. Okay, and then on the second piece, we would get -8 plus 6 plus 2, so actually this is just 0, that piece. And so what we get is 4 over 4, so just 1. That is the slope. And so next we want to find the derivative. So this is just going to be power rule, 3x squared minus 3. And when we want to find numbers that satisfy the conclusion is right up here. That numbers that when we plug them into the derivative are equal to the slope of the tangent line. So we'll just go ahead and set this derivative that we found equal to the slope of the tangent line that we also found, or sorry, secant line that we found, and then solve this. So 3x squared equals 4, and if we take the square root of both sides, we will get plus or minus the square root of 4/3, which we could rewrite as 2 root 3. So our answer will be that we could take c to be positive 2 over root 3 or negative 2 over root 3. Okay. And then lastly, we have one more theorem that we will go over in the next video.